Okay, today we'll take a look at the application of quadratic functions, a very important application. You'll see this time and time again in pre-calculus, but especially calculus. And so we do introduce it in algebra too. But today we'll be looking at the equation of what we consider a free-falling object to Earth, an object that has been thrown in the air and falls to Earth due to gravity. Any object that is thrown or launched into the air, such as a baseball, basketball, or soccer ball, is a projectile. The general function that approximates the height h in feet of a projectile on Earth after t seconds is given by h, the height, is a function of t or time, and it equals negative 16t squared plus the initial velocity v sub 0 times t plus the initial height h sub 0. Negative 16 represents the constant due to Earth's gravity. An object falls to Earth 16 feet per second per second. Okay, so the first second is falling 16 feet per second. The next second it falls 32 feet per second, and so on and so forth. So negative 16t squared. The initial velocity represents how fast something was initially thrown, like a football, for example. And the initial height would represent what was the initial height from which it was thrown. Okay, so this model does have limitations because it does not account for air resistance, wind, and other real-world factors. If you become an engineer, you'll modify that equation quite a bit, okay, but the basic equation will still be there. So let's take a look at example 1. A golf ball is hit from the ground with an initial velocity of 80 feet per second. So in this case here, the initial height is 0. It's hit from the ground. The initial velocity will be 80, and v sub 0 will be 80, and of course we still have the constant due to gravity, which never really changes. So the equation will be h of t is equal to negative 16t squared plus 80t. 80 was the initial velocity. Again, the initial height is 0. And so now we can ask some questions here. When will the ball reach the maximum height, and what will be the maximum height, and what does this represent? Now, the next thing about this, and you'll have a take-home test, but the nice thing about this take-home test is that you don't need to use a calculator or do calculations to answer these questions. You just need to know how to use decimals and write an equation, which is really, really important. So we'll take a look at using decimals to help answer these problems here. So I'll go out to decimals, negative 16t squared plus 80t. I have to remember that. Okay, so negative 16t, or negative 16 x squared plus 80x. So we're looking for the initial for the maximum height. So initially, again, at time 0 is kicked from the ground, and then it goes up, and right there at the vertex is 2.5 seconds in 100 feet. So 2.5 seconds in 100 feet. What does that represent? Well, it represents the vertex. It's the maximum of that quadratic. After how many seconds will the ball hit the ground? What does this represent? So again, if I go back out to decimals, now I'm looking for when the ball hits the ground. So it goes up, and then on Earth, what goes up must come down. And in 5 seconds, it lands. Okay, so 5 seconds. So that represents the zeros or roots. Represents the 0 or roots of that equation. See, we didn't actually have to solve. We didn't have to complete the square or factor or using another method to find the zeros. We just use decimals. All right, so that's one equation where we don't have an initial height, but we have an initial velocity. No initial height, but initial velocity. Let's look at another equation. So let's say in example 2, a rock is dropped off a cliff 200 feet above the ocean. So you kind of see the picture up there. The cliff is 200 feet, and then somebody's going to drop a rock off, and it's going to land in the ocean, so make a big splash or whatever. All right, so let's answer some questions here. Okay, write an equation to model this situation. All right, so it's dropped, so it doesn't. There is no initial velocity. It's just dropped off the cliff. So if I go back up to this equation, v is 0, but we do have an initial height. Okay, and that initial height is 200 feet. It's 200 feet above this ocean. And of course, we still have gravity at negative 16 feet per second, or negative 16 t squared. So there's a model where we have an initial height, but no initial velocity, just initial height. Now again, we would graph that. So 200 minus 16 t squared. So if I do that, 200 minus 16x raised to second. I want you to notice here, in this example, I'll zoom out. Yep, at the vertex it should be 200 feet because that's where the rock was dropped. Okay, so we have a negative 0, but in the context of this problem, that doesn't make sense. And you can't have negative time anyway. That'd be going back in the past. So basically, everything starts at 0. At x is equal to 0. That would be our domain. We start at x is equal to 0. And then we want to know when it lands in the ocean. Well, that would be the 0 of that function when that graph crosses the y-axis, and that's at 3.5 seconds. 3.5 seconds. So after how many seconds will it take before the rock falls in the water? Well, 3.5 seconds. And that represents the 0 or root. When you guys go to take the ACT, you can bet, guaranteed 100%, you will see these type of problems. Okay, so again, that one represented we had an initial height but no initial velocity. This one represented we had an initial velocity but no initial height. Guess what the next one's going to represent? If you said we'll have an initial height and initial velocity, you are right. Okay, so we're going to have both of those. I'm going to change that because that's exactly example 3. Okay, so here a quarterback throws a football with an initial velocity of 72 feet per second. Okay, and the ball is thrown from a height of 6 feet. All right, so we want to write an equation to model this situation. So the initial velocity is 72, so 72t, and again we're using this equation here. Negative 16t squared plus v sub 0 t plus h sub 0. So the initial velocity is 72 feet, and the initial height is 6. So our equation is negative 16t squared plus 72t plus 6. When will the ball reach the maximum height? And what will be the maximum height? So again, we have to enter this in decimals, negative 16, 72, and 6. Okay, so negative 16x squared plus 72x, plus 72x, and then plus 6. I'm pretty sure that was the equation. Yep. Good, and then we're looking for when the football hits the ground. So again, we have a negative 0, but that doesn't make sense. Again, you can't go back in time. So, and then we're looking for the maximum height. So actually, we're looking for the vertex. I don't know if I said 0. So in 2.25 seconds, it will reach a maximum height of 87 feet. 2.25 seconds, it will reach a maximum height of 87 feet, and that will represent the vertex. After how many seconds will the ball hit the ground? Okay, so again, we have to go here, and keep going, and okay, so there we go. All right, so in 4.6 seconds, I guess 4.6 seconds, the ball will hit the ground. And again, what does that represent? It represents the zeros or roots. Okay, so you have a take-home test on a problem like this. Expect to see one of these three. Either you have an initial velocity and an initial height. Here you just had an initial height, no velocity, and here you had initial velocity but no initial height. So one of the three.